Welcome to Astronomy 103, the Solar System. I teach at Prince William Sound College in beautiful Valdez, Alaska. This video will explore more of the outer solar system. I'm going to share some of the most interesting discoveries about rings and moons of the giant planets. Learning about the moons of the outer planets is one of my favorite parts of this class. So much has been discovered, but there's a ton we don't know. The moons around Jupiter, Saturn, Uranus, and Neptune are like mini solar systems. I'm going to hit on the highlights of these moons in my tour of the outer planets. Let's start with the ring systems of these giant planets. What are the beautiful rings of Saturn and the invisible rings of the giant planets made of? Wait, did I just say invisible rings? Yes, all four of the Jovian planets have ring systems. The invisible rings on Jupiter, Neptune, Uranus are not easily visible using conventional telescopes. Well, unless the light is just right to be reflected off. It wasn't until the 1970s when faint rings were confirmed around these three giants, with the Voyager 2 probe passing by Uranus in 1986 and Neptune in 1989. The rings are dark, like charcoal, and patchy. It is thought that the rings are formed when one of the planet's moons was destroyed. So, the rings of Neptune are very dusty, and Uranus, the rings are made of dust, rock, and organic compounds that have been baked in the radiation of space. Astronomers are now studying the rings with infrared and radio telescopes. Here's an image of Uranus in infrared bands. The rings are thin and bright in these longer infrared wavelengths. We can actually see them from Earth observatories in the high desert mountains of Chile. Much more is known about Saturn's bright rings. Of course, you can actually see the rings of Saturn if you had a telescope on a dark night when the giant planet is visible from Earth. We know that Saturn's rings are made up of tiny icy particles, and we know the rings are razor thin. Imagine that the rings are only 30 kilometers thick. When the rings are 270,000 kilometers in diameter. So 30 meters to 270,000 kilometers is like a piece of paper that's 100 kilometers long. That's how thin it would be. We know much about these rings thanks to the Cassini spacecraft and its 13-year mission around Saturn. Cassini flew through the rings on its final journey as it plummeted to Saturn. It took stunning high-resolution photos on its last lap, and it taught us much about the composition of the rings as it flew through them. Here's an image that shows a portion of the inner central part of the planet's B-ring, moon, that is actually carving a hole in the ring. Saturn has many moons close in, and these impacts on the moons release fresh material into the rings. Cassini made a surprising discovery that Saturn's rings are much younger than previously thought. According to Fraser Cain in The Universe Today, data from the Cassini mission shows that Saturn's rings may only be 10 to 100 million years old. They may not have actually been there during the age of the dinosaurs, and in fact, a fairly modern development in our solar system. Let's look at the fantastic moons of the outer solar system. These moons range in size from a tiny 5 kilometers across to the larger than planet-sized Mercury. They are numerous and actually are still being discovered. Jupiter has 79 moons and Saturn has 82, but we are going to highlight just a few. It's interesting to note that the larger moons we'll look at are all spherical, they're icy. Besides that, there's not a whole lot in common. These outer large moons are so different from our terrestrial Luna. Many of them are geologically active. They are made mostly of ice, water ice, and other frozen hydrogen compounds, along with some rock. Now, with an icy moon, a little heat goes a long way in melting it compared to melting rock. So that's what causes a lot of this geological activity. Is it from the sun? Nope, that's too far away. It actually comes from a force known as tidal heating and from some radioactivity. Here's a summary of some of the more active moons. I mentioned that tidal heating plays a part in the active geology. Io, Ganymede, and Europa line up every 7 days in an orbital resonance as they orbit Jupiter. Jupiter, is the largest and king of the planets. It has a lot of gravitational pull. Well, Io turns out to be the most volcanically active body in our solar system. It has hundreds of active vents that blast jets of volcanic snow hundreds of kilometers into the atmosphere. But it's not just snow. It can flex enough to melt the rocky interior and vent sulfury lava too. Next is the moon Europa, and NASA has its sights set to send a probe there. Europa is covered with fractured watered ice, and there's evidence of a subsurface ocean. It also has a weak magnetic field, and we know there is liquid water with evidence of vents of it being sprayed into the atmosphere. We hope to send a probe through those vents, and we can get a better analysis of what is exactly in that salty water. According to NASA's Solar System Exploration page, scientists think that Europa's ice shell is 10 to 15 miles or 15 to 25 kilometers thick, and it's floating on an ocean 60 to 150 kilometers deep. So while Europa is only 1/4 the diameter of Earth, its ocean may contain twice as much water as all of Earth's oceans combined. Okay, well, let's look at Ganymede next, the largest moon, larger than Mercury, the planet Mercury. It has its own geological activity, and you can see in this image that there's older cratered terrain and younger areas with these grooves and ridges. And we know that there's surface ice on Ganymede, and it has a magnetic field. The fourth moon of Jupiter that we'll cover is Callisto, and it has a super cool name. I always love that name, Callisto. It's the third largest moon in the solar system. It's heavily cratered with bright spots of ice. It may have a subsurface salty ocean, we're not sure. It would be pretty deep, and it also has a magnetic field. So those are the moons of Jupiter. We're going to move on to the moons of Saturn. If you thought Jupiter's moons were fascinating, wait until you learn about Saturn's. Out of the abundance of moons, 3 moons stand out. The first 2 are Enceladus and Titan because they're big and active. And the tiny third moon, Mimas, has to be covered because, well, it's just so weird. Jupiter's Europa became the first famous ocean world, but Saturn has its own icy ocean world, Enceladus. Cassini flew close enough, 25 kilometers above the surface, to take these high-definition images. It's super white and shiny. The surface of Enceladus is like Antarctica. The spacecraft was able to sample a spewing ocean vent. What did it find? Yes, it found liquid water under the ice, and it's full of minerals from hydrothermal vents that have ingredients for life. Other facts about this planet is that it's tidally locked with Saturn, and it takes about 33 hours for 1 day. Tidal heating accounts for much more heat radiating out of the South Polar region than was expected. Global ocean, organic chemistry, and internal heat show that Enceladus is a promising place for life, nestled within the rings of Saturn. Okay, the next moon of Saturn I'm going to cover is Titan. It's the largest moon, Titan. And it is different from any place in the solar system. Why? Well, because it's the only moon with an atmosphere, though it is a strange one, and more atmospheric pressure than Earth, and it has mostly nitrogen. And so it's dense enough that you could walk around in very warm clothes without a spacesuit. Well, think Antarctica. Just bring your own oxygen. Titan could be the best candidate for humans to colonize because, well, there's lots of energy as it has lakes of liquid hydrocarbons like methane and ethane. I can just see a future colony. Anyway, there's a cycle of methane rain. The surface of Titan is a crust of water ice. Under the crust, there's shown to be liquid ocean of water that could harbor life as we know it and water for us to drink. NASA is going back to Titan with a battery-powered drone, Dragonfly, to explore more. You can't learn about the moons of Saturn without covering the weird Mimas. The small moon looks like a Death Star. It is the smallest known body known to reach a round shape in the solar system, and its most dramatic feature is the impact crater Herschel. That's almost a third of the diameter of the moon. Let's look at the sideways planet Uranus and its moons next. Okay, something twice the size of Earth slammed into Uranus 3 billion years ago and made it the oddball of our solar system. There have been no detailed missions to the sideways planet, so we don't know much about the moons, but they appear to be half water and half ice. Here are the 6 largest moons relative of size. From the small to large, we have Puck, Miranda, Ariel, Umbriel, Titania, and Oberon. These are known as the literary moons, as William Shakespeare wrote in Midsummer's Night Dream. Sweet moon, I thank thee, moon, for shining so bright. These moons are named after Shakespearean characters. There are 27 known moons, and they are far away from the sun, 2.9 billion kilometers. Notable is Miranda, the innermost major moon, and it has crazy surface. Miranda has giant canyons 12 times deeper than the Grand Canyon with terraced layers of different ages. Lovely Ariel, the moon, has the youngest and brightest surface. We really need to learn more about these distant moons. The last planet in the solar system, Neptune, has one moon I want to highlight, Triton. Now don't confuse it with Saturn's Titan. Titan is big. Triton, well, Triton was a mascot of my alma mater, UCSD, and we used to say, what the expletive is a Triton? Well, it's a seashell and a lesser god of Greek mythology. Well, that's fitting for Neptune, the god of the sea. Far from the sun and moon as you can go, Triton is shiny and reflective. There's just little light that hits the surface, and it's one of the coldest objects in the solar system, minus 240 Celsius. The other cool thing about Triton is that it circles the planet Neptune backwards, opposite in the direction of planet's rotation. So it may have been captured by icy Neptune. It may have got knocked around in some collision. Well, I've covered the highlights of the moons of Jupiter, Saturn, Uranus, and Neptune. The takeaway is that there's so many fascinating features on these distant rings and moons. They beckon to be studied more to reveal the secrets of the solar system.